Hi, my name is Amar.
And my name is Rachel.
Today we'll be explaining the selection sort algorithm. Selection sort divides the array into two sections, the sorted section and the unsorted section. We start off by grouping the entire array as the unsorted section. We then take the first element of the unsorted section and list it as our minimum. We will then compare that element to every unsorted section.
If one of the unsorted elements is less than the minimum, that element will be listed as the new minimum. At the end of each iteration, the minimum will be switched with the first element in the unsorted section. Selection sort will then iterate through the unsorted section, skipping over the already sorted section. So, we start off with the first element of our unsorted section, which is the number 8. We then compare it with the next element in the unsorted section, which is 2. Since 8 is greater than 2, 2 is our new minimum. We then compare 2 with 24. Since 2 is less than 24, 2 is still our minimum. 2 is also less than 10, so 2 is still our minimum. And 2 is also less than 47, so 2 is our minimum. We then switch our minimum with the first element in our unsorted section, like this. And now 2 is part of our sorted section, and 8 through 47 is part of our unsorted section. So we go through the same process for the rest of the unsorted section.
47 will not iterate through itself because we know that that's the last element. Selection sort space complexity notation is O1. The time is proportional to however many elements there are in the array.
And the time complexity for selection sort is O(n) squared, because the time it takes is directly proportional to the square of the number of elements in the array. And since selection sort must go through each element, no matter if the element is already in the right position or not, the best case scenario and the worst case scenario are both n squared.